Have you ever wanted to change shape, like to morph into something different? Well, there's actually a subatomic particle called a quark, and in this domain, there's this other subatomic particle called a down quark, and it can do just this. It can transform into a different being in a matter of nanoseconds. And today, we're going to discuss this in Physics in 5, hosted by Maggie Berry. So before we delve into going into what a down quark is, let's define what a quark is. And no, it's not that. So for a long time we thought that, protons, neutrons, those are the smallest existing particles on Earth. But actually, they're not. They're these things called subatomic particles that make up the protons and neutrons. And these are called quarks. And so what a quark is an elementary particle, and it can form hadrons, which the most stable example of a hadron is a neutron and a proton. And so quarks are elementary particles that experience all four of the fundamental forces, which are gravity, electromagnetic forces, the strong forces, which holds the nucleus together, and the weak, which is the radio force, which results in radioactive decay. And so quarks, there's around 6, and the heaviest quarks go under particle decay to transform into the lighter weight quarks, and the lightest quarks are the up quark and the down quark. And because of the law of the mass, which always goes towards stability, the down and the up quarks, which are the lightest, are the most common quarks in the universe because they make up protons and neutrons, which make up everything that you know. A neutron is made up of 2 down quarks and 1 up quark, and a proton is made up of 2 up quarks and 1 down quark. So let's take a step back in time. In the 1950s, new hadrons were discovered by the eightfold way and the flavor symmetry by this scientist named Murray Gell Mann. And then in 1968, there was evidence of quarks, and these two men, independently of each other, named Mann and Zweig, sorry if I mispronounced your name, Mr. Zweig, proposed the quark system, which included the down quark. And in 1968, there was evidence of quarks via this Stanford Linear Accelerator Center. That's where they found it. And they used this deep inelastic scattering experiments, which indicated that protons have substructures made up of down and up quarks. The down quark is symbolized by a circle with a lowercase d. It has a mass of 4.3, a spin of 1/2, and a charge of -1/3. So why are quarks so important in our day-to-day life, and how do they interact with the world? Well, they make up protons and neutrons, and those are pretty important because they make up every single living thing. Like everything that you're seeing, protons and neutrons are part of those. So without them, you would not be here. And so they also interact with the 4 fundamental forces. And so first off, we have the weak nuclear force. And the weak charge gives rise to the weak nuclear force. And this causes the down quark to change to the up quark by emitting or observing a W boson. And you don't need to worry about what that is. And by doing so, though, any down quark can become an up quark and vice versa. And that's really important. And this, transforming is called flavor transformation. Pretty cool. So the down quark's electric charge of -1/3 is the generator for the electromagnetic force, which surrounds the smallest part of the down quark. And we're going to see a visual of this in just a second. A down quark interacts with gravity because, it just follows the rules of gravity. It doesn't, spring off into outer space on a limb. So the color change that we were talking about earlier, with the red, blue, and green, generates the strong nuclear force, which is the 4th fundamental force. And so this strong nuclear force is 100 times greater than the electromagnetic force. But the range of this force is really, really small. But this is the force that holds the nucleus together. So, what's a cool use of the down quark in like everyday life? Well, it's actually used in PET scanning, which is positron emission topography. And PET scan is like, you'll see that in the doctors. And what this utilizes is the down particle and the up particle being able to like transform into one another via beta decay. So, what would a day in the life of a down quark look like? Well, it has a pretty long lifespan compared to like the bottom quark, which has 1.3 times 10 to the negative 12 seconds lifespan. So, down quark has 900 seconds. So, it's pretty like ancient compared to the other quarks. But it's so fundamental in our lives, and it's like changing all the time that it would just be like, wow, like it would just be crazy.
Thanks for watching Physics in 5.